All right, stationary points example 3. Find the greatest and the least value of y equals x cubed minus 6x squared plus 5 on the interval minus 2, x is between negative 2 and 5, including both endpoints. Okay, so let's see, what does this mean? Find the greatest and the least value? Well, that looks like it's asking me for a maximum or minimum type question, but it's saying the greatest of all of the values, okay, and the least of all of the values on this interval from negative 2 to 5. So that means we're actually going to be we're going to have to find the global maximum and the global minimum. Okay, so we do need to consider the endpoints in this case, because local maxima and minima can sometimes be global max or minima, but we still need to consider the endpoints. Okay, so we're going to do the same thing. We're going to find the derivative, use the sign diagram to find the intervals of increase decrease, see if our critical values are local maxima or minima, and then compare those y values at those points with the y values at our endpoints. Okay, so let's find out what dy dx is. We derive that and we get 3x squared minus 12x. Okay, and that just turns out to be, if I factor out a 3x, I get x minus 4. Okay, so if I set this equal to 0, you'll see that the zeros occur at x equals 0 and at x equals 4. Okay, I don't have any vertical asymptotes to deal with, so that's nice. I'm just going to use these two numbers to create my sign diagram. Let's create the sign diagram over here. Remember, the sign diagram is of f prime of x, or dy dx. Okay, so we have a 0, we have a 4, I have 3 intervals to test to see whether it's positive, negative, or positive or negative. Let's try over here. If I put a negative number in here, I have negative times negative, so that's going to be positive. If I put a 2, or let's put a 1, I'm going to have positive times a negative, so that would be negative. And if I put a 5, I'm going to get a positive and a positive. Okay, so I have here, if I'm going from positive to negative, I'm increasing then decreasing. That's going to look like a maximum. If I'm decreasing then increasing, I'm going to have a minimum value. Okay, so I'm going to have a graph that looks something like this, and that makes sense because this is a cubic again. All right. So let's go back to the question. What is the value of these? What is the value of each of these critical points? So I need to find the y values of this point, and probably the end point, right? Over here. I'm going to have a negative 2 somewhere and a 5 up here somewhere. So I need to find out what those y values are. So the way we do that is you can just plug those numbers into here. Okay, so you just basically have to find what f of, let's start with negative 2, because that's the endpoint, f of 0, f of 4, and f of 5 are. Okay, and those would be my y values that I'd need to find, right? Okay, and you can just use a calculator for this probably, unless they're real nice numbers, then you could do it. I'll just give these to you. This turns out to be negative 27. F of 0, if I plug 0 in, I get 5. If I put 4 into here, I get 64 minus 6 times 16 plus 5, and if you add all that up, you get 27. Minus 27. F of 5, if I put 5 in here and 5 in here, I would end up with a minus 20. Whoops. Whoa. Okay, minus 20. And so you can see that this is my global max, right? Oops, global maximum. And I have 2 minimum. Okay, this number and this number are both my global minimum. Those are the least values of y. So my final answer would be, I guess, the global maximum occurs at global maximum is 5 at x equals 0, or you could say at 0, 5, I guess. A global minimum, in fact there are two of them. The minimum value of y is going to be negative 27 at x equals negative 2 and x equals 4. Okay, so you'd have negative 2, negative 27, and 4, negative 27. So these two are my minimum values. And notice that it's because of this interval that we've chosen these 2 points. All right.